So in this lesson, we will be analyzing this graph provided to us, and it involves questions 52 through 57. So again, dealing primarily with limits. So let's begin here. So question number 52 states that the limit of f of x as x approaches 3 is equal to what value? And again, the main idea with limits for now as in pre-calculus is that the one-sided limits should be equal. Only if the one-sided limits are equal, then the limit overall does exist. If the one-sided limits are not equal, for instance here as you see, x approaching from the right hand side is approaching this value over here, x coming from the left hand side is approaching this value here. So the one-sided limits are not equal, therefore the limit of f of x as x approaches 0 does not exist. So that's the idea here. When we're talking about limits, we're talking about this idea of the function approaching a particular value. So here when we have the first question, limit of f of x as x approaches 3, well really here the function is defined at the point 3, right? And if it's defined at that point, there's no confusion because you can take values less than 3 or greater than 3 and you should see that your graph is approaching the value 4, right? In fact, at the point 3, the value 4 exists. Therefore, limit of f of x as x approaches 3 is equal to 4. Then for number 53, we have limit of f of x as x approaches infinity. So we're saying that x is infinitely going, it's infinitely increasing right towards the positive side. Therefore, it's approaching infinity. So limit of f of x as x approaches infinity is really this asymptote here, right? This horizontal asymptote. So this is equal to 2, and it makes sense because you're saying that the value that is being approached is 2 because you are going in this direction infinitely and your curve is approaching this 2, right? Because there's a horizontal asymptote there. And then for question number 54, we have limit of f of x as x approaches 2 plus, and this 2 plus over here, right, this sign over here indicates that we're talking about the direction from the right hand side. So we're saying that as you approach from the right hand side, right, towards 2 here, what's happening to the y value? So limit of f of x as x is approaching 2 from the right hand side, right? For instance, this means 2.001, 2.0000001, right, closer and closer to 2, right, this value over here. And so we see that this answer over here should be infinity, right? Because as you go closer to 2 from this direction over here, you're approaching that positive infinity. So our answers here for 52, 53, and 54 are 4, 2, and infinity respectively. So those are those 3 questions. Now I have the next 3 here. So question number 55 is limit of f of x as x approaches 0. Then number 56 is limit of f of x as x approaches negative infinity. And then we have for 57 limit of f of x as x approaches negative 5. So we want to evaluate these three problems here, right? So looking at 55, limit of f of x as x approaches 0, and this is the one I was talking about earlier. Your one-sided limits are obviously not equal. Here from the right hand side you're approaching positive 1, from the left hand side you're approaching negative 1, therefore your one-sided limits are not equal and there is no limit at this point. So for question number 55, your answer is does not exist. Then comes question number 56, limit of f of x as x approaches negative infinity, right? So we're talking about going in this direction, the left hand direction, right? Here infinitely. So we look at this, so limit of f of x as x approaches negative infinity. While looking at this curve will infinitely go in this direction, right, approaching this horizontal asymptote. So therefore, like problem number 53, where it was limit of f of x as x is approaching infinity, same concept here. We're saying that for number 56, limit of f of x as x is approaching negative infinity is also positive 2. Again, the reason being is that you're approaching that horizontal asymptote at y is equal to 2. And now we have number 57, limit of f of x as x approaches negative 5. So here we see that there's a hole here, and this is a good example, right, where you have that removable discontinuity. Whenever you have removable discontinuity, there's a good probability, right, or that a limit will exist for sure, right, because you will be approaching that hole from the right hand side and from the left hand side. You're approaching this same value, right? So this is obviously 0, because as you approach negative 5 from the right hand side and as you approach negative 5 from the left hand side, you're approaching 0, right? You're approaching the y value of 0. So limit of f of x as x approaches negative 5 is 0. Now if you have a jump discontinuity like this, right, you see this jump discontinuity, usually a limit will not exist, because usually you will be approaching different values from the left hand side and from the right hand side. However, for removable discontinuities, you will have a limit that exists. And then obviously the third one is your asymptotic discontinuities, and for those limits may or may not exist. It depends on the type of asymptote that there is. So those are 56, 55, 56, and 57 here, and so really those are questions 52 through 57 that I've just went over here, right? And so utilizing this graph, we understand the concept of limits, and I think the main idea that you really want to take away is that the one-sided limits must be equal in order for the limit to truly exist. So thanks for watching.